So I'll start this question by solving part B and C first and ending with part A. So starting with part B, since we know that the formula K equals Fz E raised to power negative Ea by RT, in this case the value for Fz is equal to same as given. So K equals alpha E negative E raised to power A divided by RT, and in this case T is equal to same. So the value of activation energy will be high because the value of K is low and vice versa. Hence, when K is high, the activation energy will be very small or negligible. The highest reaction rate is for reaction number 2. So the highest reaction rate will be for reaction number 2. That means the activation energy will for reaction number 2 will be less. So as we have shown, if the activation energy is higher, the reaction rate will be low. The lowest reaction rate will be for reaction number 3. So the lowest reaction rate, K is 0 and K high. The lowest reaction rate will be for reaction number 3 because the activation energy is high. Moving on to part C. The most endothermic, that means the most reaction will be reaction number 3. That means delta E will be positive. The lowest reaction rate, that means K, is for reaction number 3 because the activation energy is high. So if the reaction is highly exothermic, the most negative delta E will be negative for reaction number 1. Moving on to part A, let me start by representing all the reactions. So I'll use the same graph to represent all the reaction, starting with option 1. Yeah, starting with reaction 1. Here is the minimum state. The delta E for reaction 1 will be equal to 60 kilojoules per mole. Over here we have the reactants that goes to transition state and leads to the formation of product. This state is called transition state, and the activation energy required is represented by EA. Here the initials are reactants. This is potential energy, and this is the reaction progress. And final, we have products. Reaction 2, the only change in reaction number 2, let me represent it by red. The only change in reaction number 2 will be the change in activation energy, which will be 20 kilojoules per mole. Rest, almost all things will remain the same. And for the representation for reaction 3, let me use green. The activation energy required will be 15 kilojoule per mole. But in this case, the reactants will go on from the lower end of the reaction. The reaction will go like this. For reaction number 3. and they will end at the upper line. For this case, the activation energy required will be EA.